Hello everyone and welcome back. So in this video we're going to be kicking off a new little mini series of videos in session 9. This will be the creation of the Terrain Manager. Now Lee, you've talked a little bit about the Terrain Manager up to this point. So what exactly is it going to be doing for us again?
Well, if you remember from session 7, a lot of the code that we dealt with, the panning of the world as Shannon was running around,
Right.
basically creating the new patches in front and removing the ones behind, a lot of that code all took place in the train demo file, in that train demo class. And I went through, when we were setting up this project, one of the very first things I did was go into the train demo and just nuke all that code, got rid of it completely. What the train manager does is essentially what all that code used to do. So it is pretty much the heart of the train system as far as orchestrating what patches need to be created, when they need to be created, what needs to be visible, when it needs to be visible, and then remove patches when they're no longer needed.
Now, trust me, I totally like that you have this a lot. I prefer it. But at what point did you start thinking, hey, having a terrain manager, that might be a good idea?
Well, a lot of it was when I started looking at performance issues that we were having with the old system,
Okay.
because a lot of it started dealing with multi-threading, and then the multi-threading is one aspect that required a lot of communication between the different systems and coordinating stuff. So once you start messing around with multi-threading, there's some very specific cases that you have to start looking at, specifically with the accessibility of lists and dictionaries. And as you're working with objects inside of memory, they have to be basically sequenced. So when multiple threads are accessing them, no two threads are allowed to access and manipulate a list or a memory location at the same time, where we get unpredictable results.
Right.
So as I was messing around with the multi-threading system, the coordination of all these different systems became more and more complicated, and it just became a huge tangled mess. So, and that I pretty much sat down and go, okay, this is not working. So that was the birth of the Train Manager. The Train Manager was initially designed as a class to manage all the communication from the various systems that make up the terrain system itself. So at one point, this class was monstrous because of all of the different locking and conditions and signaling that had to happen between all the various systems. At one point, I think this class was about 700 or 800 lines of code. So that was just a mess, and I was not happy with it at all. So I started redesigning systems, moving things apart, breaking them apart. What you'll find is, for the most part, this new version of the train system has no multi-threading in it. I've pulled it all out, which meant that all of the sequencing and the communication between the systems got removed completely. So the final train manager that I have right now that we're going to be looking at is about 149 lines of code.
Okay.
And then there's some other things I'm going to implement, so the final count by the end of this little set of videos may change, but it's significantly simpler. And a lot of that came about by the new way that I'm dealing with the patches, meaning that patch builder and the patch dispatcher, or the patch dispatch that we spent the last couple of videos doing. So what I've done is I've broken things up into their own system that I could offload from the train manager. So basically the train manager just now goes, oh, your character's here is looking at in this direction. So if I don't already have patches in that direction, I should probably create them. So I'm going to tell the patch builder, or I'll actually create patches, and then tell the patch builder to get them all set up whenever it gets a chance to.
Okay.
And then the patch builder worries about when those get created and put those in order and take care of the grunt work. And then the train manager just goes, oh, okay, well, the character's looking over here now. turn these patches on, turn those ones off, and if the characters move so far away, get rid of these patches. So all the signaling is been greatly simplified. Removing the multi-threading from this has reduced, the amount of code, significantly, like cut it into 1/4, a little bit more than 1/4 of what it used to be. So, and along with that was significant performance improvements across the board. So that's why the TerrainManager has evolved to become what it is now.
Cool.
So I guess we can start coding it up. So let me go ahead and stop Unity. So bring up our code. Let's go and close out a couple of these things that we had open when we're fixing the issues with the third-person controller. And open up code, train system, create a new class. And this will be our TerrainManager. Now in this first video, we're going to, just like all the other videos that we've started off with, we'll start with cleaning up the namespace and putting in our initial fields and properties. I'm going to make this a public static class. Now I'm going to warn you ahead of time. At one point in time, we had multiple train systems that were at various resolutions, patch densities, and I had an instantiable TerrainManager. So I would have 2 or 3 TerrainManagers that were all working at different resolutions. I was using different cameras for each one, and I was doing some visual tricks to composite them together. I'm no longer doing that. This new system is only going to use a single TerrainManager. Now that I'm only going to use a single TerrainManager and I'm not going to have multiples, I'm going to turn this class into a static. So the code that I have that I'm taking my notes from is still that instantiable. So I'm going to be converting the static on fly.
Yay!
So I'm just warning people now because we all know how well that usually turns out for me. So I'm going to just prepare you ahead of time for that. So let's get some initial fields going. These are going to be, they're going to be read-only, but we're going to set them the first time and not worry about them ever again. This is going to be our size and our spacing. So we've got those. And then a new one that you guys haven't seen yet is going to be our interest range. Now this is going to be how far out from the character's position in patches do we care to have loaded inside of memory? Well, that we're going to load. So basically, when our character drops in, it's going to go, oh, okay, my interest range is, say, 25. So it's going to go, oh, all right, so I'm going to subtract 1, divide by half. So my true interest range is 12 patches out from my position in all directions. So it's going to load those in. Now, that's the first one. I have another one that is a hold range. Now, the difference between the two, interest range is what it's going to load in. Every time you move, it's going to try to load in all the patches within the interest range. As you move around in the world and patches get removed, that's going to be the difference of when to remove. So I can have a smaller interest range and says, okay, if you're in here, load these patches. But if I move past that interest range, those patches aren't immediately going to disappear. They're still going to stay in memory. They're going to stay in memory until the character has moved beyond the hold range of patches. So if our distance is greater than the hold range, then those patches will be deleted. That's just to give us a little bit of buffer, so if somebody runs in one direction and then decides to backtrack in a little bit and then turns around and starts running in the original direction again, we're not constantly deleting and removing those patches as they cross the interest range boundary. There's that little dead zone.
Mm-hmm.
So it's just another little way of optimizing the performance. So there used to be another one, a visible range, which was the range at which I would determine whether or not something was visible. So I would say, here's the visible range. If you're within the visible range, I'm going to enable those mesh renders. If you're outside the visible range, I'll disable those patches. And then that worked on a shorter range than the interest range. I'm removing that. This is also another modification that I'm doing on the fly, because I have in the Train Viewer, which is even newer than my build of the Train engine, I've implemented a way of looking at the frustum of the camera.
Mm-hmm.
So we're going to use the frustum of the camera to determine if the patches are going to be visible or not. This is going to tighten up our amount of patches that are going to be displayed even better than using a visible range, because the visible range would give us a circle of patches.
Right.
And with using the frustum of the camera, we just get this small cone of visible patches.
Mm-hmm.
Again, the reason I'm showing these optimizations is because this is something that everybody can do, whether or not they have the standard or the pro version of Unity. So it will give you some built-in optimization in case you don't have pro and you won't be able to use the asset bundle streaming that we'll be using later. This will just help you use this part of the system even more efficiently than I was going to originally show. So, all right, with that said, let's create a couple more fields. These are going to be a private static, and let's do private static. This will be a vector 3. This is going to hold our player position. And let's see, a private static read only. This will be an int. This is tile side count. Now what tile side count is basically going to be our interest range minus 1 divided by 2. Because if you remember the way we build out our patches are centered around the player's position.
Mm-hmm.
So that is the patch that we're on. Tile side count is the number of patches to the left and right or front and back that we're going to create patches out from the player's position, as opposed to using just the interest range, because the interest range would be the total across left to right of patches that I would like to see. So I can say I have an interest range of 25, which means I would have 25 patches across and 25 patches down for a total of whatever 25 times 25 is.
Mm-hmm.
So I could pull out the calculator, but I won't. So that will be our tile side count. Let me go ahead and group some of this together. So put this up here. These are my publics. Take this one, move this one up here. Player position is just going to be where the player is in the world, so we can keep track of our ranges so we can build our patches as needed. Now, we're going to need some static properties. We'll do a, let's see, what do I want to have? Public static a vector 2, and this will be a player position. And this will have a get and a private set. Speaking of which, let me take this, move that down here. We'll come back and we'll flesh that out a little bit later. And then I need a public dictionary. This dictionary is going to use a vector2 for a key, and it will hold train patches as its value. And I will call this patches, if I can spell it. Get a private set. And why are you not happy? Oh, yeah. Probably should make it static. There we go. So we've got those. And then let's do a public static game object. Now, this game object is going to be our train object. I'm going to hold this as a get with a private set. This object is going to be what we're going to parent all of our train patches to, or at least all of our train mesh objects to. If you remember, our mesh objects come in right now, they just fill up the player. What am I trying to call it? The project. So our hierarchy here. So when I hit play, all of our train patches just jump in here. And that can get very messy, especially when you have hundreds of these things inside of it. So this train object is going to just be an empty game object in which we're going to take all of our train patches and parent those to it. And then when they're no longer in use, those objects will get reparented to the object pool game object. And we'll just switch the parenting back and forth between those two. So I'll go ahead and ignore that for now. And then let's see. Let's make a couple of properties. So we'll get a public. Do I want this to be public? No, I'll make this. No, let's make it public just in case. So this will be public float patch size. That's good spelling. Yeah, I saw it. So get return. Now our patch size is going to be size -1 times spacing. So, and I also need to make this a static. So that will give us our patch size. And we need to figure out what is the current patch that we're standing on. So if you remember, our player position is going to be in world position, but our patches are in offset. So basically, if we're X units by Z units in world position, we need to translate what those would be to a patch, or what patch would be in that position. So to get our current patch location, I will use an equation. That equation being return a new vector3. Oh, I see what I did. Yeah, sorry, vector2. And that will be mathf dot round to integer. I'm going to use our player position dot x divided by our patch size. And then we'll do the same thing again for z. So that will get, hold on, player position, I see what it's saying. Okay, it's going to be here. Now, let me think about this. Do I really need this anymore? No, I won't. So let's kill this one. Let's use this. And that will be Z, not Y then. And of course we need to make it static.
There you go.
All right. So now let's see what we've got. Size, spacing, player position are never used. We will in a little bit. But let's see, is that all my properties? Yes, it is. All right, so that should have us covered with our fields and properties. I reserve the right to make changes as needed as we go forward because I am doing this on the fly. So,
All right, is that everything for this video?
yeah, and this one. The next one will come back and we'll deal with the constructor.
Fantastic. All right, thanks everyone, and we'll see you guys over in the next video.